Next, we're going to look at the derivative of sine and cosine and composites. So we're going to graph sine of x in a standard trig window. So our calculator should always be in radians for calculus, always, always. So if you do sine of x, and then if you do a zoom trig, it'll fit a nice pretty window that shows a trig function very well. So there's our graph of sine. Now, and you can jot that down in your notes. Now I'm going to graph the derivative. Okay, so alpha of 2 derivative d dx of y1 when x equals x. Well, that function should look familiar. Okay, it looks like the sine, but rather than starting at 0, 0, it starts at 0, 1. So what function does that? Yes, cosine. So the derivative of this function is cosine of x. Okay, so on a note card, the derivative of sine of x is cosine of x. Let's investigate cosine. Okay, so let's go back. I'm going to turn the derivative off for now. And I just want to graph cosine. Good old cosine. Okay. On your own notes, in your own head, I want you to make a prediction on what might be the derivative of cosine. Have your guess? All right, let's go ahead and turn the derivative on and see if you guessed correctly. Now, the normal guess is, well, if sine is cosine, then cosine's derivative would be sine. But if we look carefully at this graph, it does go through 0, 0 like sine does, but it's going down rather than up. So this function is actually negative sine. So the derivative of cosine of x is equal to negative sine of x. Okay, so that's again a note card. So the derivative of sine of x is cosine. The derivative of cosine is negative sine. And I will provide a proof of these because there is a way to prove this using the definition of a derivative if you're interested or you're convinced by the calculator and you're good to go. Okay, so next we're going to graph 2 cosine x, which of course we know changes the amplitude. So predictions on the derivative. You make your own prediction. Let's confirm or deny. And if you guessed negative 2 sine x, you are correct. So the derivative function is y equals negative 2 sine of x. And we said that with the power rule, that if I'm just multiplying by a constant, then the derivative is going to get multiplied by that constant. All right, let's go ahead and graph cosine 2x in our standard window. So 2x, again, we don't want to ruin the surprise, so we're going to hide our derivative. And there's cosine 2x. Okay, so again, make your prediction. What do you think the derivative is going to be? So you can make your conjecture, and now we're going to graph it and see if your thinking is correct. So if you said negative sine 2x, you are not correct. It is a negative sign, and it is a 2x. It has the same period as the blue one does, but it's twice as tall. So the actual derivative of cosine 2x the derivative here is negative 2 sine 2x. So we started with this, and our result was this. So the derivative of cosine is that negative sign. The 2x kind of went along for this, right? So where did this 2 come from? All right, let's try another composite. Cosine x squared. Again, we don't want to ruin the surprise. All right, this is cosine of x squared. Kind of a wacky little graph there. Okay, and you can make your prediction about the derivative. Let's go ahead and graph the derivative. So that's a pretty crazy graph as well. But again, it's matching the slope. So the slope of those different things at different points. So likely your guess for the derivative was negative sine x squared. Or at least that's what maybe. Okay, so what I'm going to do is I'm going to take the actual derivative, which is in y2, and I'm going to divide by my guess. Okay, and I'm only going to graph that. Okay, it's got a lot of thinking to do to graph this. Okay, so all those wacky graphs, I took my actual derivative and divided it by my guess. The result is this line here. If we trace, let's trace to 1, we get 2. Okay, if we trace to 2, we get 4. So we're left with a 2x. Okay, so let me illustrate how this plays out. Okay, 4, and I'm just going to use some white space here. So I took the derivative, let's say f prime of x, and I divided out negative sine x squared, and the result was 2x, which means that this derivative is 2x times as big as the other one. So the actual derivative here is y f prime of x is equal to a negative 2x sine of x squared. Okay, so my f of x was cosine 2x, cosine x squared. So what we got, the derivative of cosine is negative sine. The x squared just stayed on the inside, so where did this 2x come from? Well, the 2x is the derivative of the inside. So what would be the derivative of cosine of x to the 1/2? Well, if we're saying we're multiplying by the derivative of this, then we're going to have a negative 1/2 x to the negative 1/2 cosine x to the 1/2. I take the, no, sorry, sine. it would be negative 1/2 x to the negative 1/2 sine, x to the 1/2. There. You can graph it to confirm. But the conclusion here is, if I had cosine g of x, my derivative is going to be negative sine of g of x times whatever the derivative of that inside part was. And this is your quick introduction to the chain rule.